All right, now it's the preview for chemical equilibrium requested by, actually she left, okay. Requested by a student who actually left. But I think it's a good thing. I'll briefly talk about, this is your reader, this on your reader. Yeah, I've been showed a hard copy, I just didn't bring it today. It looks like a lot of the mathematics I can show you. This on your reader. There's a flow chart. There's a flow chart on your reader before each chapter starts. Okay, I'll talk about what are those, or what are you expecting to get from this. Okay, you are expecting to do something like this. I will show you a little bit. We're also going to do this in the class, but I have a cool demo, which, what do you call this? This timer? Sand timer? What do you call this? You don't know? Just like how long does it take? Like this one is 3 minutes.
Hourglass?
Yeah, I think it's
Okay.
hourglass, right?
Hourglass. Okay, I don't know what the name. Okay, I'll just say it's a timer, but probably you have a better name than I do. Whatever. How it goes is the sand goes from one side to the other, right? Okay, this is exactly what you think about. This one side is the product, the other side is, this is the reactant, this is the product. The whole reaction works, theoretically everything now, is how your reactants disappear, how your product appear, right? This is all we're doing. This is visualize. What does this whole chapter do? By concentration, or by how much your reactants remain. Okay, your reactant, I'll use R for reactant, okay, starts with the whole, right? Very soon, just like you're visualizing them now, they decrease, right? Product, start from 0 at a certain point. With no decreasing of your reactant, your product is going to be just like not going to increase anymore. This is chemical equilibrium. Chemical equilibrium describes when you plateau, okay, when there are no loss of your reactant, when there are no gain of your product, you reach a state called chemical equilibrium. However, what's that going to do with the things in my hand? Before we teach this chapter, you are assumed the whole reaction goes complete, which means you are expecting all reactant. That's limiting reagent, right? You use all of them up. Whoever use up first is going to be the limiting reagent. All of them become the products. This is before equilibrium chapter. Chapter 1 to 5, you are here. Starting from chapter 6, this is chemical equilibrium. You won't really see a scenario all your reactant is going to use up. It's not happening in the real case. We are teaching you what's in the real case. The equilibrium will be this. You still have some reactant left over. Your product is not going to increase, even you have some left over. However, how do I know this? This chemical equilibrium is based on reaction, which means I have reaction 1, okay, reaction 2, 3, 4, 5, whatever. I have so many reactions. This reaction, how much they are going to left? At what extent they are going to reach, like let's say, I start with this much. What if I start, it's the same reaction, okay? What if I start with this much? Am I still expecting I left that much over? Okay, is there a way I can calculate based on how much reaction I increase in order to get the certain amount of the product I can pull out from that reaction? How do I deal with that? The whole chapter is based on the calculation of once your reaction is set, just like once this timer is set for certain type of reaction, it's always going to be the same amount ratio. That's at this ratio, your reaction stop. Could be here, okay, some of the reaction could be a little bit higher. They just don't want to react anymore. It's reaction based, just like it's the timer in my color. If it's the same reaction, it will always have the same curve. If you change the reaction, just like I changed the timer, you are going to have a different curve. You are expecting they are going to left over with different amounts. So the whole chapter just from the timer that I show you how much sand remain to the calculation specifically on math, okay, on paper, I can calculate how much will be remain. That's it. Okay, that's it. Yeah. Oh, 5 minutes.